In this video, we will learn how to derive the indirect utility function from the given consumer's utility function and the prices she is facing and the income of the consumer. The question is, if the consumer's utility function is given by utility derived from two goods x1 and x2 is equal to x1 raised power 1 upon 3 times x2 raised power 1 upon 3, she faces prices p1 and p2 for good x1 and x2 and her income is m, which is m denotes the income. We need to derive the indirect utility function for the given consumer. Okay, so to derive the indirect utility function, so let us see what we have been given. We have been given the utility function, that is utility derived by consuming good x1 and x2, which is equal to x1 raised power 1 upon 3 times x2 raised power 1 upon 3. Okay, and we also need to construct the budget constant for the consumer. So what will be the budget constant? That will be price of good 1 times units of good 1 plus price of good 2 times units of good 2, and it should be equal to the income of the consumer. To derive the indirect utility function, what we need to do? We need to find out the Marshall and demand functions for good x1 and x2. To find out the Marshall and demand function, we need to maximize the utility function of the consumer subject to the budget constraint. Okay, so graphically, how do we maximize the utility function? So if I draw a simple graph here, so let us suppose we have good x1 on the horizontal axis, good x2 on the vertical axis, with the given budget. Okay, if I draw the budget line, consumer's endeavor will be to maximize his utility. That means he or she wants to reach highest possible indifference curve. Let us suppose this is IC1 and let us suppose this is IC2. Okay, now the optimal consumption bundle will be at a point where the indifference curve and budget line are tangent to each other. That will be our condition to find out the Marshall and demand function. That is the demand function for good x1 and x2. Having said that, and what is the tangency condition here? That is, at tangency, what happens? So first order condition for optimization requires that we equate the marginal rate of substitution between good 1 and 2 with the ratio of the prices, that's price of good 1 upon price of good 2 here. Okay, we also know that marginal rate of substitution, it denotes the slope of the budget line. So MRS simply denotes the slope of indifference curve, and it should be equal to the ratio of the prices, which is the slope of budget line. Okay, now we also know that marginal rate of substitution between two goods is simply the ratio of the marginal utility of good 1 and marginal utility of good 2. It should be equal to the ratio of the prices P1 upon P2. Okay, now marginal utility of good 1 is simply the change in the utility due to the change in the consumption of good 1. Likewise, marginal utility of good 2 means the change in the utility due to the change in the consumption of good x2, and it should be equal to the ratio of the prices P1 upon P2. Okay, now mathematically it is marginal utility of good 1 is simply the partial derivative of utility function with respect to good x1, and marginal utility of good x2 is the partial derivative of utility function with respect to good x2. Having said that, now let us find out these partials here. Now first we need to find out the partial derivative with respect to good x1. Using power function rule, exponent of x1 becomes coefficient. So we have here, let me write it here. So we exponent is here 1 upon 3. So we get 1 upon 3. Then we have x1, and exponent is subtracted by 1. 1 upon 3 minus 1. So 1 upon 3 minus 1. So 1 upon 3 minus 1 is 1 minus 3 upon 3, which is equal to minus 2 upon 3. Okay, so we get here minus 2 upon 3. x2 remains same as 1 upon 3. Likewise, we need to take the partial with respect to good x2 to find out the marginal utility of good x2. So again, the exponent becomes coefficient. So we have 1 upon 3. x1 remains same as 1 upon 3, its power, but the exponent of x2 is subtracted by 1. So we will get x2 raised power negative 2 upon 3, and it should be equal to the ratio of the prices P1 upon P2. Okay, here doing some cancellation, we can cancel out this with this. Okay, one thing we can do here, that is, if I transpose this x2 to numerator, it will get multiplied, but the exponent sign will change. If it is minus 2 upon 3, it will become plus 2 upon 3. So let me do it here. So we will get x2. Here we have 1 upon 3. If I transpose this, it gets multiplied, it becomes x2, but plus 2 upon 3. Simple algebra. Likewise, here we have x1 raised power 1 upon 3. If I transpose numerator to denominator, again exponent sign will change. So we will get here, it is minus 2 upon 3, it becomes plus 2 upon 3. And it should be equal to the ratio of the prices P1 upon P2. Here bases are same, we can add up the exponent. So we will get x2, Hamza side, x2, bases are same, we get here 1 upon 3 plus 2 upon 3. Likewise, here we will get x1, bases are same, we can add up the exponents. So we will get 1 upon 3 plus 2 upon 3 should be equal to the ratio of the prices P1 upon P2. So here it will sum up to 1. So we will get x2 divided by x1 is equal to P1 upon P2, which implies x2 will be equal to P1 upon P2. Transpose this x1. Okay. Having said that, now transpose, rather put the value of x2 is equal to this stuff into the budget constraint. So we will get, we have P1 x1 plus P2. In place of x2 we write this P1 upon P2 times x1, and it should be equal to the income of the consumer, which implies P2 gets cancelled. We have P1 x1 plus P1 x1, it will become twice P1 x1 should be equal to the income of the consumer, which implies x1 will be equal to m upon twice P1. This is our Marshallian demand function for good x1, which is simply a function of income and price. Likewise, if we want to find out the Marshall demand function for good x2, what will we do? We plug x1 equal to this stuff into this equation, and we will get x2 will be equal to m upon twice P2. Okay, so these are our Marshallian demand functions. To find out the indirect utility function, what we need to do? We will plug the Marshallian demand functions into our direct utility function. That is, our indirect utility function will be, so our indirect utility function will be a function of prices P1, P2 and income of the consumer. Okay, so plug x1 and x2 into this equation. So in place of x1 we have m upon twice P1 raised power 1 upon 3. Okay, I hope I am not deviating from in the space. Likewise, for x2 we have m upon twice P2 raised power 1 upon 3. Okay, now if I try to solve it further, so indirect utility function will be P1, P2 and m. Okay, so we have m raised power 1 upon 3, m raised power 1 upon 3, it will become m raised power 1 upon 3 plus 1 upon 3 is 2 upon 3 divided by, so 2, here we will get 2 raised power 2 upon 3 okay, then P1 raised power 1 upon 3. Sorry for this stuff. So now solving further, you can solve it by yourself. Okay, so if you want to solve it further, you can do the simple algebra. That will be our indirect utility function. I hope I make myself clear in this video. Thank you.